Hello friends, myself R.D. Mahajan presenting my video on Maclaurin's theorem. Or its statement is like this. The expansion of f of x in ascending powers of x is known as Maclaurin's theorem. And it is given as f of x is equals to, first term is f of 0. F of 0 means value of the function at x is equals to 0. Next one is x into f dash of 0 plus x square by 2 factorial into f double dash of 0. Next, x cube divided by 3 factorial f triple dash of 0 and so on. The last term is n x raised to n divided by n factorial into nth derivative of f at x is equals to 0. If we observe the terms are in increasing powers of x or ascending powers of x, and whenever we require the expansion of that given function in terms of ascending powers of x, we have to apply a Maclaurin's theorem. And all that f dash, f double dash, f triple dash, all this represent the successive derivatives of fx. Then we try to see some standard expansion. First standard result, expansion of e raised to x as 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. If we see the right hand side of this expansion, it is in terms of increasing powers of x, and as it is in terms of increasing powers of x, it becomes the problem of Maclaurin's theorem. Therefore, we try to see the proof of this result. Simple proof. Here the given fx as e raised to x, we try to differentiate it with respect to x successively. Therefore, first derivative f dash of x as e raised to x. Again differentiate it, we get f double dash of x as e raised to x. Third derivative f triple dash of x is e raised to x and so on. And then we require to find the values at x is equals to 0. And therefore we get first one f of 0, put x is equals to 0, we get e raised to 0 and the value of e raised to 0 is 1. Next, f dash of 0, again e raised to 0, that value is also 1. Next, f double dash of 0, e raised to 0, 1. F triple dash e raised to 0, that is equals to 1. And therefore substituting all this in Maclaurin's series result or theorem, we get f of x as e raised to x. First one is f of 0, the value of f of 0 is 1. X into f dash, the value of f dash of 0 is 1. Next one is x square by 2 factorial, f double dash is 1. Next, x cube by 3 factorial, f triple dash and so on. And therefore we get a first standard series result for e raised to x as 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. A required result. Second result, prove that sine of x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial and so on. Here it is in terms of increasing powers of x, and it exists for odd values of x only. And therefore to prove this, let given f of x as sine of x, we try to differentiate it successively with respect to x. We get first derivative of sine x is cos of x. Again differentiating it, we get f double dash derivative of cos as minus sine x. Third derivative of sine is cos with this minus sign, therefore it becomes minus cos. Fourth, differentiation of cos of x is minus and this minus, it becomes sine of x. Fifth derivative Derivative of sine is again cos of x, and so on. Then we try to find out the values at 0. X is equals to 0, we get f of 0 as sine 0, and sine 0 is 0. F dash of 0 as cos 0, and the value of cos 0 is 1. Next, f double dash of 0, put x is equals to 0 here, we get sine 0, and sine 0 is 0. F triple dash of 0, cos 0 is 1, and therefore we get minus 1. Next, fourth derivative at x is equals to 0, sine 0 once again, sine 0 is 0. And lastly, fifth derivative at x is equals to 0, we get cos 0, and cos 0 is 1. And therefore substituting all these values in equation 1, if we call this as equation 1, that series becomes f of x is here sine of x. First term is f of 0, the value of f of 0 is 0, plus x into f dash, the value of f dash of 0 is 1, plus x square by 2 factorial, f double dash, it is 0, plus x cube by 3 factorial, f triple dash as minus 1. Next, x raised to 4 by 4 factorial, value is 0 for a fourth derivative. Next one is x raised to 5 by 5 factorial, and fifth derivative as 1, and so on. And therefore, if you simplify the terms, we get the required result. First one is x into 1 means x. This becomes 0. The third term, next term is minus sign, therefore it is minus x cube by 3 factorial. Next 0. And next term is x raised to 5 by 5 factorial, and so on. Therefore, we get the required result for sin x, series for sin x as x first term, second minus x cube by 3 factorial, third one as x raised to 5 by 5 factorial. Terms alternately positive, negative, and values for x exist for odd values only. The terms with even power becomes 0. Therefore, remember this as the second standard series. Sin of x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial. And after derivation, we can use this as a standard series or standard result to solve the problem or to find the expansion. Third standard expansion, cos of x is equal to 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial, and so on. And to obtain this result, once again we consider fx as cos of x, differentiate it 4 times. Differentiation of cos of x is minus sin of x. F double dash of x, derivative of sin x is cos x with this minus sign, therefore it becomes minus cos of x. Third derivative, derivative of cos x is minus, and this minus it becomes plus sin x. And fourth derivative is derivative of sin x is cos of x, and so on. We can find infinite number of derivatives. And then f of 0, put x is equals to 0, we get cos 0 as 1, f dash of 0 sin 0 with minus sign, sin 0 is 0, f double dash of 0 cos 0 with minus sign, therefore it is minus 1, f triple dash once again sin 0 Sine 0 is 0. And fourth derivative at x is equals to 0, cos 0, it is 1. And so on. And therefore, substituting these values in equation 1, that equation 1 becomes f of x. The function is cos of x, for which we require to find the expansion. F of 0 is 1 plus x into f dash, it is 0, plus x square by 2 factorial, f double dash, it is minus 1, plus x cube by 3 factorial, f triple dash, 0, plus x raised to 4 by 4 factorial, into fourth derivative as 1, and so on. And therefore, we get the required result. First term is 1, next 0. It is minus x square by 2 factorial as a second term for that expansion. Next one, plus x raised to 4 by 4 factorial, and so on. Terms alternately positive, negative. First one positive, second negative, third positive. And the power for x is even only. Means terms with odd power does not exist or becomes 0. Therefore, we get the required series for cos of x. 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial, and so on. Fourth result, sin hx, sin hyperbolic of x as x plus x cube by 3 factorial plus x raised to 5 by 5 factorial, and so on. Here, all terms with positive sign, and therefore to obtain this, once again we consider fx as sin hyperbolic of x. Differentiate it successively, we get first derivative as cos of hx, cos hyperbolic of x. Derivative next, differentiation of cos hx is sin hx. Third, derivative of sin hx is cos hx. Fourth, derivative of cos hx is sin hx, and so on. We get the corresponding values at x is equals to 0. F of 0 sin h 0 is 0. F dash of 0 cos h 0, and value of cos h 0 is 1. F double dash of 0, again sin h 0, that value is 0. F triple dash at x is equals to 0, cos h 0, it is 1. Fourth, sin h 0, 0, and so on. Therefore, substituting that values in this Maclaurin series result, we get f of x. F of x is here sin hx. First term f of 0, value is 0. X into f dash, the value of f dash is 1. Plus x square by 2 factorial. F double dash, it is 0. Plus x cube by 3 factorial, it is 1, and so on. We get the required series. The first one is x, next becomes 0. Second term of that series is x cube by 3 factorial. Next one becomes 0 as fourth derivative 0. Like this, we can extend it. Next one, it is x raised to 5 by 5 factorial, and so on. The terms all are with positive sign, and it exists for odd power of x only. Therefore, we get the required result. Fifth result, series for cos hyperbolic of x as 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial, and so on. And to obtain this, once again we consider f of x as cos hyperbolic of x. differentiating it with respect to x. First derivative is sine hyperbolic x. Next, differentiating it, we get next derivative as cos hx. Third derivative, differentiation of cos hyperbolic is sine hyperbolic x. Next, fourth derivative as cos hyperbolic of x, and so on. Finding corresponding values at x is equal to 0, f of 0 is cos h0, 1. F dash of 0, it is sin h0, that is 0. F double dash of 0, cos h0, once again 1. F triple dash sin h0, 0. Fourth derivative at x is equals to 0, cos h0, and it is 1. Substituting all these values in that Maclaurin series result, we get, therefore, cos hyperbolic of x is equal to, first term is f of 0, 1, plus x into f dash, it is 0, plus x square by 2 factorial, value of f double dash, it is 1, x cube by 3 factorial, value of f triple dash, it is 0, x raised to 4 by 4 factorial, f fourth derivative, it is 1, and so on. And we get the required result. It is, first one is 1, next one is x square by 2 factorial, next 0, the next one is x raised to 4 by 4 factorial, and so on. Here the terms with positive sign and terms exist for even power for x. All the terms with odd power become 0, and therefore we get cos hx. Then I will explain how we get the derivative of sin hx as cos hx and derivative of cos hx as sin hx. I have written that directly, but here I will explain it how we get. We have two equivalent results. Equivalent result of sin hx in terms of exponential as e raised to x minus e raised to minus x by 2, and cos hyperbolic of x as e raised to x plus e raised to minus x by 2. And then when we differentiate it with respect to x, derivative of that sin hx as differentiation of that right hand side term with respect to x, it is e raised to x minus e raised to minus x by 2, 1 by 2 constant outside. Differentiating each term with respect to x, derivative of first term is e raised to x minus, differentiation of e raised to minus x is minus e raised to minus x, and we get that one as e raised to x minus minus will become plus e raised to minus x by 2. E raised to x plus e raised to minus x by 2 is nothing but cos hyperbolic of x. Means we get the derivative of sin hx as cos hx. Then differentiate this result for cos hx. Therefore, derivative of cos hx means derivative of the right hand side term with respect to x. It is e raised to x plus e raised to minus x by 2, 1 by 2 constant term outside. Differentiating each and every term with respect to x. First derivative of the first term is e raised to x. Derivative of e raised to minus x is minus e raised to minus x. But this e raised to x minus e raised to minus x by 2, that term is nothing but sin hx. Okay, and therefore remember this derivative. Differentiation of sin hx is cos hx, and derivative of cos hx is sin hx. We are not getting anywhere a negative sign, like for circular function the derivative of sin x is cos x, and derivative of cos x is minus sin x. But for hyperbolic, we are not getting any minus sign. How? That I have explained with the help of this simple proof. In next video, I will discuss the remaining standard series. For if you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thanks for watching.